Hello, everyone. Hello, we're going to start. Um, spreadsheets and dashboards. Speaking about performance, well, I really like spreadsheets and dashboards, and I will use those terms interchangeably all the time. So if I say spreadsheet, it works for dashboard. If I say dashboard, it works for spreadsheet. Um, what do you do when you have a nice toy? Well, you play with it. So this is the wish list number by talk, and welcome then to the second most wishlisted talk to the developer track in this event. I think you did well to come here. My name is Vincent. If you have questions, you can scan this QR code and open the pad, ask your question there. We'll reply to them in the end. If we don't have time to reply to them, you can also come to the booth, which is on like all the way there, and to the spreadsheet and BI developer booth. We will reply to all the questions there as well. When we speak about performance, I think the most basic but important part is to set the expectations right. So this is the expectations that I have for our spreadsheet and dashboard engine. Anything that contains less than 10,000 elements should be instantaneous. It should be like a blink of an eye. Anything from 10,000 to 100,000 elements, well, it can take some time to load. It depends also on your computer. It should still work up to 3,000 elements. Anything above that, well, this is when the problem starts to occur. And this is also when we need to take actions to make things faster. The good news is that there are a lot of things that you can do when you design dashboards and when you design spreadsheets to make them faster. You don't need to be a developer to do it. You just need to be very aware of all the features that we use and use them properly. In order to explain to you what are those tips that you can use in order to make your spreadsheets faster, I think the best thing to do is to explain to you how the architecture of spreadsheet works, like all the moving parts, and then go one by one into each part to see what you can do. So let's say you want to open a dashboard, a sales dashboard. The first thing that Odoo will do is go to Python, like load the action and look up the dashboard. And the dashboard is composed of two parts. The first part is what we call a snapshot file. It's a JSON file. It contains the definition of everything that is in the spreadsheet. So the biggest your spreadsheet is, the biggest your snapshot file is. And the second part is the revisions. It's stored in your database. It contains everything that changed in your spreadsheet since the last snapshot. So if you copy-paste something and other people are working with you on the same spreadsheet, you will have revisions created one after each other. And the snapshot plus the revision together makes the spreadsheet or the dashboard. We take this definition and we send it to the browser. Your browser is going to do the heavy lifting. It's going to try to understand the formula, load the rest of the data, parse everything, and so on. And the first thing that we need to look at is how do we keep the snapshot files as small as possible, because smaller is better, it loads faster, and it's less work for your browser. The first thing that you can do in order to make your spreadsheet faster is turn the repeated formula into an array formula. And array formula is a mouthful. There's other words for it. Vectorization is another word. So the goal of this is to have one formula that writes values on many cells. Let's take a very simple example, so we are sure to understand each other. So on the left here, I have a small spreadsheet. It contains number from 1 to 15 in the column B, and then in the column C, a formula that just says, look up the cell next to it, and copy its value. It's very simple. How can you turn that into array formulas? Well, if you look at this column, all the formula are very much the same, with one reference that is the difference. And that's the only difference, is just referencing one after the other. So you can rewrite this as in the first cell equal B2 column B16. And this one formula will write on all the cells under it until you have 15 values. So I had 15 formulas on the left. I have one on the right. And while we are working with array formulas, I had numbers on the left. You can also write that as an array formula. This equal sequence 15 writes 15 numbers, one under each other, from 1 to 15. So just here, I had as many formulas as I had lines on the left, and on the right, I have exactly 2 formulas. It doesn't matter the amount of lines I have. So I have already divided by 15 the size of my file, which is a pretty good thing. And now you're going to tell me, yeah, but my formula are not that simple as yours. They are really big, and I have like lookups and so on, and it's very difficult to see what I can turn into an array formula. So something that we did, not for turning formulas into array formulas, but to find error in formulas, is actually quite useful to find out what you can turn into a formula. So let me open this file. I have purposefully set an error in it. So this file is full of formulas, and all formulas are quite complex, reasonably complex. See, it's an index with matches and so on, and if you click on it, everything blinks because all the things are referenced. What it does is really not important. The only thing that is important is that there's an error. Quick question, did you see the error? Did you spot it? You did? Good. So now let's see. Now you should be able to spot the error pretty easily. So what I did is I turned on the feature that's called irregularity map. What it does is it takes every cell, and then if there's a formula in it, it will compute with a mathematical operation using all the references and all the parts of the formula, what the general shape of the formula is, and all the same shape gets assigned the same color. And so you can see that in this column, everything has the same color. In this column, everything is the same color. And then in this giant zone, everything is the same color, except this cell. Well, it's a mistake. I hard-coded a 0. Let's fix the mistake. Okay, now it is I autofill the formula down, so that I copy the formula from above. Now the formula is correct, and I can transform this into an array formula. How would you do that? Well, it's very easy. The first thing that you need to do is know how far you need to go. In here, I need to go to line 70. And then I will take one of the references, drag it down. Do the same with the second reference, drag it down. And now I turn my formula, arbitrary complex, into an array formula. If I do that, well, probably I made a mistake, right? Because everything is in error. But actually, no. I need room to put all my values of my array formula. And it says exactly, the error says, I want it to write something in D13, but I can't because there's already something in D13. That's the formula that was there before. So let's remove everything. And now, because I'm still in the irregularity map mode, the highlight changes. I have turned this entire column into one single formula. It writes all the values one under each other. And I can do that for this column. And then also this column, it becomes quite more complicated because this formula is more complicated. But still, same principle. You can take the references, increase them or type them. So I need to go towards D70, and here too, towards D70, done. Now I have turned twice a formula that was repeated on every line into a formula that spans as its result all the lines, but is only defined once. If you do that well enough, well, this is an example of optimization that I did on this specific file that you saw. The first version was the first graph here. The size was about 160K. The loading time was about 120, 110 milliseconds. And after I went through all the steps of optimization, like 1D vectorization for the lines, then 2D vectorization for the large parts for the columns. And then I turned all the formatting into a data table, and I used a dynamic pivot, and that gives me an end file that is less than 10K. So from 160K to less than 10, and I didn't lose any feature. It's not like I removed data or changed formatting. I didn't lose any feature. It's just optimization. Okay, about array formula, that's the hardest part. It needs a bit of developer tools, I mean, a developer mindset to increase the difficulty of the formulas. But what you can do, and that's very easy, is turn static pivots into dynamic pivots. Dynamic pivots have been introduced a long time ago. They have all the features of static pivots that you get when you insert a pivot from Odoo out of the box. And when you insert a pivot in Odoo, from Odoo in a spreadsheet, every cell contains one piece of the pivot, and it's defined like that. So you have a formula that says this pivot here is like this header, and this cell here is this sum, this cell here is this detail. With the dynamic pivot, it's just the formula equal pivot, and then the ID of the pivot. Everything is written all at once. Once again, one formula, many results. Something that is very useful that you already saw last year and was stressed again this year was computed measures inside pivots. So one of the things that is useful is you have a pivot and you want to compute something about this pivot that doesn't exist in your data source. Once again, if you write the formula inside the definition of the pivot using computed measures, you write the formula once, and then it will write on every cell that requires this value. So if you write this formula and you have many, many levels and sublevels, it will write the results on all those levels and sublevels of group bys. So it's same story, written once and results many. Speaking about formatting, you can use like borders and background colors and bold and everything to format your spreadsheets. It works fine, but the thing that is better for performance is to use data tables, because it's same as the formulas actually. If you write on many cells that you want background color dark, well, you need to write that somewhere and it needs to live, and then if you add more cells, it needs to live as well. If you take a really big range and says, I want a data table, the data table itself will say, okay, this column is a header, this column is a one odd column or even column, same for the rows, and it's defined only once, so it's very efficient. All right, so everything I said right now was about keeping the size of your snapshot small. If you keep it small, it runs faster, it's lighter, it's obvious. And now what I want to talk about is keeping your revisions small and also have as few as possible. Revisions are created all the time for you. Every time you change something, a revision is created, and the revision describes the change that you just did. Why do we do that? We do it so we can send it to everybody else that is connected to the same spreadsheet, and you can follow the changes that are made without having to re-download the entire spreadsheet. So in theory, really good idea. Sometimes in practice, a bit less of a good idea. And let me show you how bad it can become. So I want to compare the revision that is copying 10 by 10 square of cells with the revision of duplicating an entire sheet. So this is the revision to copy a 10 by 10 square of cells. So 100 cells, it takes the first one, look at its format, look at its value, and tell you, okay, well, you need to format this like this, and that's the value you should put. And same for the next one, same for the next one. This is the revision to duplicate a sheet. It just said, well, duplicate that sheet. So you can see there's one obvious winner in terms of performance. If you need to have some data that was somewhere else, duplicate your sheet. It's much better to duplicate your sheet and remove all the things that you don't need than to copy-paste. It's going to be more efficient. You will create smaller revisions, and so everybody is going to be happier. It's very much possible to break your spreadsheet by having too big of a revision. If at some point you go over the hard limit of 600 megabytes, Python will not be able to load them. Your spreadsheet is broken, and we need to go in the database and remove the last revision in order to load it. So duplicate is better than copy-paste. We do revisions every time you change something. Obviously, it's not efficient if you have very long-lived spreadsheets. So once in a while, when you close a spreadsheet, we take advantage of one small hook in the browser to collect all those revisions, put them together, and then rewrite the snapshot file so it becomes the newest snapshot. And then the new revisions will be added afterwards. If you make a lot of changes, if you make very big changes, like large copy-paste, even if you know now that it's probably not the wisest thing to do, you can snapshot manually. It's in file snapshots. You have to be in debug mode to do that. And why do you need to be in debug mode to do that? Because if you do that while other people are using the spreadsheet at the same time, they will have a very small deconnection, reconnection, because we will force them to reload the spreadsheet at some point. No data is lost, but still, it's not something that you want everybody to do all the time. All right, so you had all your data loaded into your browser. You had your snapshot and your revisions. They were processed, and now the spreadsheet engine needs to somehow figure out what the value should be of equal pivot 3 in this specific cell of this dashboard. Well, obviously, it needs to do a read group in Odoo on Python. Read group will collect all the data, and the data is sent to your browser again. So not only do you need the definition of the dashboards, but you also need the data that runs on the dashboard inside your browser. What does it mean? Well, it means that if you have plenty of data sources that are not used, it's wise to remove them. Just throw them away. If it's not used, there's a small triangle next to it that tells you it's used nowhere. You can safely throw them away. If you made a mistake, you can still undo and recuperate them after you have removed them. So I said, the browser has a lot of things in memory. It has the definition, the revision, the data sources. It also does a lot of computation on your computer, in your browser. We need to catch up to get the latest version, parse and understand all the formulas, plot charts, and all those things. But I didn't talk about all the other things that a spreadsheet needs in order to run smoothly. One of the biggest things that we need in order to run things smoothly is keep track of the dependencies between one cell and another cell. So if you say in A1 equal B2, well, then B2 becomes a dependency on A1, and if you change B2, you need to change A1. And this is true for pretty much everything inside a spreadsheet. If you have graphs that reference ranges, if you have conditional formatting, and so on, basically everything can depend on anything else. And this is all stored in memory. It's also true for a few things that are hard to compute and computed very often, like some rendering parts. We also keep that in memory. So once again, that means your browser needs to hold a lot of information. And there are still a few things that you can do in order to alleviate a little bit of the processing. One of the things that is very often used is lookup formulas. By definition, they are slow because you need to read all the cells one by one until you find something that matches. But you can make them a little bit faster if you sort the data only once where you look up, and you use the parameter true on your lookup function. It says it's a sorted array. It will be very fast to look up. Instead of a linear search, it's doing a binary search, which is much more efficient. Finally, I have a little bit of time. I can show you something that completely breaks the spreadsheet really fast about references and elements. So I said earlier, if you have a spreadsheet that is between 0 and 10,000 elements, it should be very, very fast. Here, let's select all my cells and count. I've not max counts. I have 9,000 cells, so I'm under the very, very fast limit. And let's maybe have a look at what this has as a formula. So it's not very complicated. I have numbers from 1 to 3,000 here. In here, I have a formula that says, I want to split this string with a space, and what it will do is that it's going to fill every substring it finds into the next and the next and the next cells. Here, I have hard-coded 1 space 2 and split on space, so I will have in B 1 and in C 2. Here, I made a vectorized formula to copy the value from the previous column. And here is a VLOOKUP where I hard-coded the 2. I said you need to look up on this range, and you need to give me the third column result, which is here. The third one of this range is D. So in theory, nothing very complex, right? It's pretty simple. But if I take this formula and I just autofill it down all the way to 3,000, yeah, I didn't make a mistake. I actually double-clicked it, and you will see it's going to happen. It's very, very slow. So it should take between 5 and 10 seconds. Let's see if I can actually fill the space while keeping on talking while it does that. Yeah, it's using a lot of memory and a lot of time. Let's go and keep on going. It's done. So I'm going to show you the result. No surprise. I split the text 1 and 2. I have 2 here, and I looked up 2 into here, which gives me 2. So everything got filled in, but it took about 10 seconds to do. What happened? Like, why is it so slow? Well, in the very, very beginning, I told you you need 10,000 elements or 100,000 elements. I didn't say cell. I didn't say values or formulas. I said elements. And what counts in the elements is the dependencies that you have between everything and everything else. And in this case, I chose the very worst case of dependencies that you can have. This unique cell depends on this entire range, for which this cell depends on this range, for which this cell is empty, but somehow got its value from the previous cell. And so this is a case where I have no really good fix for you. All I can tell you is if you get into a domain where you have a very small amount of cell and it's very slow, well, there is a number of dependencies and operations that you need to do that you can probably save by maybe not doing the split, doing in a calculated form, in a calculate field, or using Studio to add that, and not do it every time on your browser. If I had written 2 in here, hard-coded, it would have been immediate, like one blink, like I said earlier, very fast. But this kind of use case, it happens. It's very easy to make a case like that, but it's also, while you look at the dependencies of everything with everything else, that you can find, well, yeah, this is quite complex step, and there's an empty cell that got its value from somewhere else in the process. So probably I can simplify this, and then everything will go smooth. So that's up to you. All right, so a little summary, very short. Remove unused data source is pretty obvious. You don't need them. Use the data tables to format. You can use array formulas in order to deduplicate your formulas, and you can find them using irregularity map. It's also going to show you your mistakes. We do mistakes all the time in formulas, so very useful. Calculated measures in pivot that are dynamic, very useful. VLOOKUP true with sorted data. And if you make many changes, do use the snapshot feature if you know what you're doing. Thank you very much. If you have questions, I will answer them now. All right. Are you reading questions? Okay. The QR code is this one. Okay, let's read them in here.
Ça marche même pas. Doesn't work.
Okay, I'm going to read them, right? So, how do you do dashboards with growing pivot data? Well, you have 2 kinds of pivot data. The one that you get the first time when you insert the pivot from Odoo, it's what we call a fixed pivot. It writes the formula in every cell. And then you have the formula equal pivot with the number, which spreads all the data in your sheet. And so this is how you do growing data, by using equal pivots instead of the default, which writes in every cell immediately. It seems that only configuration of the spreadsheet are stored in the database. Do you have a way to get the computed spreadsheet value in Python code? No, you don't. You don't, because now you understand that everything pretty much happens in your browser. So that's the browser that is parsing the snapshot file and the revision, catching you up, understanding the formula, requesting the data, and then processing the data for you. So right now, there's no way to get that in Python. Is the formula not heavier for the calculation on the browser side, meaning all computers might lag more? Obviously, yes, it happens on your computer. So the better your computer, the more you can process. But still, I think under 10,000 elements, it should go fast, even with older computers. In dynamic pivots, multiple group bys, you are aware of an easy way to identify different group by layers, unfortunately, space in front of group by. Yes, if you use dynamic pivots, you will now have the plus in front of the group by. Do I have an example? Yeah, I didn't prepare an example, but maybe come to the developer booth and I will show you an example about what it looks like right now with multiple group bys. good idea to cache read group and make pivot faster. It's of course it's cached when you load it the first time, and also if you use many times the same pivot, we only do the request once. But every cache needs to be invalidated at some point. So if you unload and reload the spreadsheet, we just throw the cache away. It's probably a good balance between fresh data and fast data. Is there a way to dynamically adopt formula based on updated? I'm going to assume pivot. If you have a fixed pivot and you want to add the data from a dimension that was not there initially, you can autofill down and left. It will try to recreate the pivot with the new data. The easiest way to do it for me would be to reinsert your pivot in dynamic and then copy the columns and rows that you want to add. Or use a dynamic pivot, which is faster. Do spreadsheets still break when data gets more record than rows set in the spreadsheet? So it's not that it breaks, it's that I want the user to be in control of adding rows and columns. Why do I want that? It would be simpler for the user so that it expands automatically. It's true. However, it also has a cost in terms of performance. Right now, you can't have millions of columns and millions of rows without any costs. So indeed, you need to add the columns and the rows yourself if you have a dynamic pivot that grows very far. If you know it's going to grow to a certain amount, you can add them ahead of time. That's fine, but it's not automatic. Did I miss any question? I think we are good. Thank you very much. I hope you learned something. Thank you.